Hello, good afternoon. My name is Dr. Garias, and I am a math tutor here at Stratford University, and I'm just going to do a really quick primer on fractions in general. So, when you're looking at a fraction, all it is a part over a whole. Okay? So the part is a numerator, and the bottom, or the whole, denominator. Okay? So when you're looking at it, just basically, right? So we're looking at a basic fraction, 1/2, and we've all seen this. It's a circle. So you look at all fractions as this. One part over how many parts that make up the whole. So the whole entire pie would be 2 pieces. And the shaded part would be 1 piece out of the whole, which is 2. So if it was 1/3, how many potential pieces? 3. 1/4, how many potential pieces? 4. 1 out of 4. 1 out of 2, 1/2, 1/3. And that's all that a fraction is. Now, knowing that all that is that a fraction is, it can be applied to other things. For example, the part over the whole, numerator over denominator. We can convert that to decimals. So 1/2. Now, the easy way to do it is you just type in 1 divided by 2 in your calculator, and what will you get? You'll get a decimal, 0.50, which is 1/2. And if you think about it, 1 entire whole is 1.00. So decimal conversion, you can convert it also to what? Percent. If it's 0.50, that's 50%. Now the ratio, which is just the ratio between the part to the whole, ratio is 1:2. So you could pretty much do this for every fraction that you ever have. And that's how you can do the conversions. Okay? So let's change it all around, and let's do 1/3. Well, 1/3 you could look at it this way. The part is to the whole, 1:3. That'll be your ratio. Okay? And part is to whole. 1 part is to 3. 1 divided by 3, if you plug that into your computer or calculator, you'll get 0.33 repeating, or 33%. And all that a percent is, percent, or per 100, 33 over 100. And you could do this for any decimal, percent, fraction, or ratio. Now, if you want to go the other way, what's 33 over 100? 33%. 33% can be written as 0.33, which is the decimal conversion. Okay? You could write it 33 over 100, and that's also a fraction. Percent is easy. All you have to do is take whatever percent and put it over 100. So 5% is 5 over 100. 10% is 10 over 100. Okay? Now that's conversions. And again, I may be going a little bit fast with this primer, but you can always slow down the video. Okay? Next, how to add fractions. Okay? Now, when the denominator is the same, it's easy. Right? You just go straight across. Because they're apples and apples. You can only go straight across if the denominators of the number on the bottom is the same. So if the number on the bottom is the same, that carries on through. And 1 plus 2 is what? 3. 3 over 2. And if you recall how to convert this, 2 goes into 3 how many times? Once. And then there's 1 left over, so 3 over 2 is 1.5. But that's assuming that what? The denominators are the same. When people get into trouble is when the denominators are different. So let's do 1/2 plus 3/5. Okay, now we got a problem. I can't do this. But what can I do? I can do this in this format. And this is what I do. I just set this up like this, no brainer. And you could also do this for subtraction. Okay, wouldn't matter. But we're adding today. So 1/2 and 3/5. Now this is apples and this is oranges. The denominator is 2 and the denominator here is 5. They don't match. So I can't just add up 1 plus 3. So what am I going to do? I got to convert it, make sure that there's a number that everything that the denominator all matches up to. So the easiest way to do it is, if the numbers are still small, is to take the denominator and just multiply them. So in this case, 5 times 2 is 10. So I can put 10 on both sides. Then I have to ask myself, 5 times what equals 10? So I got to do like 5 times 2 to make it 10. So if I do times 2 on the bottom, I can do times 2 at the top. So 3 times 2 is 6. 2 times what equals 10? And that's of course 5. So if I do times 5 on the bottom, I can do times 5 on the top. 1 times 5 is 5. 5 over 10. Now I have what? The denominators match. So now I can do what? 5 plus 6 is 11. Right? And the denominators stay the same. It's 10. If we want to convert it, how many times does 10 go into 11? It goes 1 time with 1 left over. And then do the denominator. So it's the same as 1 and 1/10. And again, I'm going a little bit fast, but you can do what? Pause the video to get the gist of the idea. Now, let's do 3/5 minus 1 over 2, or 1/2. So let's say you have this problem. And again, you could set it up the same exact way. Okay, and then 2 times 5 is 10. 2 times what is 10 times 5? If I do times 5 on the bottom, I got to do times 5 on the top. 1 times 5 is 5. 5 times what equals 10? And that's times 2. 5 times 2 is 10. Times 2 on the bottom, and then times 2 on the top. 3 times 2 is 6. 6 minus 5 is now what? 1/10 is your answer. Again, why did we do it this way? So we can convert the 3 over 5 and the 1/2 into two fractions that are equal that have the same denominator. And that's the key in addition and subtraction of fractions. You have to get it so that it'll be apples to apples, or the denominator even. When the denominators are not the same, you can't do the addition or subtraction. Okay? All right. Let's do multiplication. Multiplication is easy. 1/2 times 1/3, what do? Just multiply straight across. 1 times 1 is 1, 2 times 3 is 6. So it's 1/6. That's easy. Just multiply across. Now, how do you do division? 1/2 divided by 1/3. Well, you take one of the fractions and then do what? Switch them. So this, remember, division is just the opposite of multiplication. So I take 1/2 and then times, and then I take the 1/3 and I do what? Switch them. 3/1 instead of 1/3. So now it's a multiplication problem, and multiplication problems are easy. 1 times 3 on the numerator is 3. 2 times 1 is what? 2. If I want to convert this, how many times does 2 go into 3? It goes once, with 1 left over. 3/2 is 1 1/2. Okay? That's like the basic stuff. I'm sure you have a little bit more complicated things, but if you look at the basic things first, it'll help you a little bit. Now lastly, this is how you study for math. Math is a kind of weird thing to study for, because it's not like reading or your other assignments. Okay? So the first thing you have to do is be able to identify the type of problem. Because knowing what type of problem will then lead you to, I'm not sure, can you read this? I think I'm writing too small. So the first thing you need to do, identify the type of problem. Remember, fraction problem, we'll go through fraction protocols or steps. And that's what makes math hard. People forget the steps. And mathematicians are the only people who think in steps. Well, that's the good thing about math is once you get it, it'll teach you how to start thinking in steps, which is really, really important in any business or in any profession. So 1, you identify the type. So if you know what type of question it is, 2, practice the question with the answers. Then practice the question with answers at reach. But you try not to look at the answer. And again, the same question. Then you take the same question, once you practiced it, with answers like at reach, like your textbook is open, but it's not readily available. It's a little bit further away. And then lastly, number 4, practice without the answers. And if you can't practice without the answer, you keep on forgetting, then go back to step 3. And you do that for every math problem you see. You practice it. So let's recap. 1, you practice with the answers. Your textbook's wide open. You see the answer, and you're pretty much copying. Then you try to do it on your own with the answers at arm's length when you try not to look at it. 3rd, you try to do it without looking at the answers. Now you do this, you do this several times for every problem. You'll start to notice around the 4th or 5th problem type of the same problem type, you're going to get to see a pattern, and you're going to get to see that your hand is leading to where you need to go. Okay, that's my quick primer. Again, my name is Dr. Grimes. I'm awaiting your email as well for the other problems, and maybe I can do that. And I hope you're able to zoom in on the video and see it a little clearly. Okay? All right, talk to you soon. Yeah, but me